Identifying and analyzing problems is an important thing in the engineering field. That is why I'm going to go to stare at Kinemetric Engineering today to find out what skills they're looking for. As a global designer of high-precision measuring tools, they analyze problems every day. We will be interviewing 2 of their engineers and the technical service manager. What are some of the issues that you would analyze in your position or by others in your company?
Issues for us, or for myself, are typically within the procedural realm. So when we're designing new products and in the development stage, most of our problems revolve around incorrect drawings, incorrect specifications, lack of technical checking, and detail work. So most of our problems are procedural.
What are some of the different phases you should go through when analyzing a problem?
The phases are a little different on the development side, whereas other people would be addressing problems after something has happened. We're trying to address problems before they occur. So it is really procedural. You want to start off with a good baseline on your research, advance to drawings being done correctly, and then checking before you go into prototyping. Typically for us, if we're not asking the right questions or clarifying what we have to do, we can spec incorrect components, design the wrong things at the wrong times, and just generally put ourselves in a position we're behind our timeframes. A good example is during development of a new video measuring system. If we're not asking questions from our manufacturers of the capabilities of the lenses we're using, we can end up in situations where the lenses we've chosen do not measure with the level of accuracy we need for our products to be successful in the real world.
Well, as a recent example, actually, we built a special machine that used a microscope, which we don't typically do, but because we didn't ask enough questions of the customer in the first place, it turns out they actually didn't need a microscope machine at all. And so we're now stuck with that machine, and we've sold them one of our standard ones, which could have been totally avoided, but sort of a lack of communication caused that. We had to develop the entire machine. We bought the microscope itself, which was a special, and then we also paid to send technicians out to set it up, and then I went out and troubleshot it myself to see if we could get it to work for them. If you don't ask enough clarifying questions, you can essentially start out with a bad premise. So you'll think you have an understanding of what the customer is trying to do, but you don't really actually have a good understanding of what the customer is trying to do. Basically due to a lack of asking clarifying questions, it went through too many people, and the communication wasn't direct enough, and we wound up spending a lot of time and money investing in something that the customer didn't need in the end.
What are some of the troubleshooting techniques used by your team?
Some of the troubleshooting techniques are, the first thing is if you have a history with the machine and you know of a specific problem or you've seen a part before that has a specific problem, you can kind of start there. And then at that point, you start eliminating variables until you run up against a wall, and then you solve that problem. Our systems are fairly complicated where there's lots of parts working together. So if you know of a specific part you've had problems with before, you can start from there. However, that is not always the cause of the problem. So at that point, you want to start eliminating variables one by one until you drill down to what the actual issue is. And sometimes it could be as simple as a cable between a camera and a computer having an issue. We've had that happen. Although other times it could be the software itself not working. So until you sort of drill down like that, you really have to do that to figure it out for sure.
There is inductive and deductive reasoning. Which is better to use in your role to try and solve problems?
Inductive reasoning usually comes first, so if you know of a problem that's been recurring, it's a good way to get your foot in the door as far as the solution goes. But the deductive reasoning is extremely important because while you may have seen that symptom before, to find the root cause and the actual base of the problem, what's causing it, that's the most important thing to do. And the way that you do that is by eliminating variables one at a time until you figure out exactly what it is that's causing the problem. Then you solve that and hopefully keep that symptom from happening again.
Is there something special you look for when hiring someone that will be dealing with analyzing problems?
Yes. Kind of a special sign I look for is the merging of the soft skills, working with other people, and then the technical skills to be able to solve the technical problems.
What makes an employee a superstar in analyzing problems?
So the problem analyst superstars know how to document the problem clearly. They use methodical processes towards the solution. They can communicate those potential solutions with others, and they know how to implement the solutions.